This is section 4.3, conics. We are mostly going to be focusing on ellipses in this section. We have already done parabolas, and there's another one called hyperbolas, and we will not be doing too much with that because of time constraints. But I wanted to give you guys a visualization of what these shapes are actually coming from. And so let me go to that. This is a conic section. Basically, it's taking a plane and slicing through two cones that are nose to nose. And if you look at the first one, you already know that that's a circle. The plane cutting through it leaves a circle of what's touching the plane and the cone at the same time. The second one is an ellipse, and it's basically it's a lot like a circle, except that it's at an angle, at an angle, and so it makes it more of an egg-shaped. The third one is a parabola. You are all familiar with parabolas, and that one, as you can see, is from a plane cutting through a cone at an angle, and just one cone. The hyperbola is just like the parabola, except it's cutting through two cones, and so it makes two parabolas that are kind of nose to nose. Okay, there are some times where you'll use a plane to cut through a parabola and you don't get any of those shapes. Sometimes you'll get a point if it's lined up perfectly through where the noses touch. If you have the plane lined up with the edges of the two cones, you'll get a line. And then sometimes you'll get two intersecting lines when you cut through the cone perpendicularly. So these are degenerate conics. The general form of any of the conics of those shapes I just mentioned to you, all of those shapes can be written in this format of a general equation. You do not need to write this down. We are not going to be covering this, but I just wanted to make you aware that this is the format that it is generally written. We are going to be looking at a specific format, and that is ellipses. But before we do that, I want to review circles because this is important. It's very similar to an ellipse. And if you remember, this is the equation that we got in the first chapter. It is x minus h squared plus y minus k squared equals r squared. And that is derived, remember, from the Pythagorean theorem. We will be using that theorem quite a bit in this section. Okay, H and K are the center of the circle. So if you remember that, and R is the distance of the radius. So just make sure you write this in your notes because in the next video, we are going to be talking about ellipses, and let's compare the two.